So students, welcome back. In today's class, we learn about material, how material is selected, how many types of material are generally in engineering terms, what is factor of safety actually, and how factor of safety depends, what are the failure theories, are they, does they actually work or not. So to start with today's chapter, we'll learn about, in today's chapter 2, we'll learn about how it works and how the things are left. So let us start. So what is material? As we know, material is something, it could be a solid, it could be solid, liquid or gas that have certain properties or certain, which is made for certain applications. So it has certain properties or certain appearances. The physical appearance can be a liquid, can be a gaseous, or it can be a solid. It can be of any mean and mode. So it could also be in any state. It could also transfer from one state to one state. So it will have certain applications and so on. So as you can see, the engineering materials has been divided in four different parts, that is metal, plastic, ceramics, composites. So metal is nothing but what we know as a metal, like ferrous, non-ferrous, amorphous. Like what is metal? Like what if we consider iron, then steel, iron related things like steel, or etc. etc. Non-ferrous like aluminium, copper, titanium, tungsten, etc. Amorphous, that can be other things like we don't consider as a completely metal, like that could be reinforced elements and everything. The amorphous also can be categorized under composites also. That depends on how you manufacture it and what's not. Plastics, we know what is thermoplastic, thermosets, elastomers. Ceramics, we know oxide, nitrates and everything. So these all are the things what we are the types of materials. So let us start with the basic patterns of material what we go. So about going before that, we should know how many types of failures are there. There can be only two types of failure, that is, one is for ductile failure and one can be a brittle failure. So let us see how we select a material. Now, the first selecting a material, the selection procedure starts with functionality, safety, longevity and the cost. Now, how it works? This is the curve. This is a curve what we consider as a stress strain curve. So this is the graph. This is stress in the stress in the y direction and strain in the x direction. So this is your ductile material. And this is somewhat like brittle material that actually goes in this way. If you consider this will go in this way, something like this. So this will be all completely of brittle material. Now, going back to things, what are left, that can be that maybe a polymer may act as a polymer material, reinforced or non-reinforced. It could act as your ductile material, as well as it could work as a brittle material. So that completely depends. So how it works actually, functionality. We have to understand where we are applying the material. For example, we are applying a material where we need a minimum amount of tension, and there will be not completely tension in the entire process or entire workability life of it. What do you mean workability life? Or cycle, workability cycle, that is how much the component or a system will work. So it will depends on how much it works. So functionality depends on this. Is it entirely on a stress, or it depends on the how much stress is applied for how many times or how many cycles. So it is completely a set of things. What is the functionality? That means you have to redefine it in terms of how it works, how much hours is it working, whether force is actually working in every point of time or not, or it is periodically force is applied. So these things actually comes in action. Safety is the most prior thing. most prior thing. Functionability is first, and second is the safety. For the safety purpose, we could skip from ductile material to brittle material. Now we could also skip from brittle material to ductile material. Now the third point is the longevity. That comes from management part, the managerial part. That is why it is managerial part, because if a component is can work for certain years or certain predefined years or calculated years or calculated time, that means this product will be very successful. So this will actually help for the designer as well as the companies to have no loss of it. So this is what happens. What is cost? Now, cost effective. Sometimes a ductile material of same stress may be in the amount may be less, and bring the brittle material if the amount may be maximum. So it entirely depends on how it works and how it doesn't work. Now, there are two types of agendas. One is theoretical agenda, one is practical agenda. So theoretical agenda completely depends on the calculation and the simulation. The simulations can be done in computers, or it is also done with small prototypes. Small prototypes also. But in practical application, we try to go on a complete practical basis applications. Like we go for the testing of every components by making its small components. But in theoretical, we may do this, but in a very precise or very small section. Maximum thing is in calculative and simulated works. Theoretical agenda is something, but in practical we have to understand how we will be mimicking the complete entire things. Next is the material selections. This is what we need to understand. As you can see, let me change it to pointer to ink color arrow option. Okay. So as you can see, this is the yield point. So this is the ductile material, and this is for the brittle material. So this is the elastic zone and it is the plastic zone. So this diagram is for your ductile material and this diagram for brittle material. So what do I mean by this? The graph is now and then same till the elastic zone. That means both goes for an elastic zone, but in brittle material we can observe that it goes off after a certain elastic zones. So even mathematically or theoretically I could say that brittle material also have a proportional limit or a proportional limit. So it cannot be termed as completely as yield point, or you can say yield point of break of the cracks. As well as this also goes for the ductile material also. So this now and then everything depends on how we calculate and what else calculations are done. So this, to understand in a simple phenomenon, we have to understand the how it practically it works. Let us go back to some calculations. Okay. Screen, and it's okay. So let us consider a company A and company decides a material to be your A and B, two materials. A to be one material, B to be one materials. A is ductile and B is brittle. So it's D and it's brittle. So it's for brittle material and it's for ductile materials. A is a ductile material and B is brittle material. Now you had been asked to select a material where the maximum allowable stress will be near about your 60 megapascal. So, or 60 Newton per millimeter square. Now, 60 megapascal. You have been given with 60 megapascal. 60 megapascal. So you have to select a 60 megapascal material. That means you have to go through back to this all the situations and problem. How will you do that? There should be some protocol or rules to be maintained. The rule is that the 4 key rules: functionability, safety, the first 2 priorities, first and most priorities. Number 2, longevity, and you have to remember the longevity and your cost. So let us consider sigma ut. Okay, the sigma ut for ductile material is 8. Sorry, I have to remove its screen. Erase. Two, 8, 0, and for the brittle material is 1, 9, 0. Fine. The cost of this per kg is, let us consider ductile material to be rupees 10 per kg, and it is rupees 6 per kg. Okay, so we have to understand how it comes in action. So as we know, we'll be applying the rule of third or third rules, rule of third, or that's the industrial standards we try to maintain. That's say standards or what you say about it. So we know we will select we'll select a material which will be three times stronger than the allowed build stress. That means we have to select a material which is 3 times more stronger than this one, because we are maintaining a rule of third, as I have told you in class. So what would be 3 times? 3 into 60. So it comes near about your 180 megapascal. So you have to select a material whose yield strength is 180 megapascal. If your criteria is to work under yield strength, sorry, it should be Y. I'm sorry, it should be Y. So you have to consider a material which could have the yield strength of till 180 megapascal. Why 180? Because I have told you that why yield strength, because will be considered below in terms of elastic limit. Now, which material will select? This one or this one? We will select this one, this brittle material. Now, why will select the brittle material? Why not the ductile material? Because number one is the cost. Number 2, ductile material has a tendency of extension or elasticity more than that brittle material. So as I know, the brittle material yield strength is 190 degree. That means I have a margin of 10 megapascal. Understood? So I have a margin of 10 megapascal. So but 10 megapascal I have margin. So I could say that I am in the safer side. If I go for the maximum stress, it's also in the safer side. If I consider for my lower stress 60, I am in the safer side. So you could also see that the margin of my selected stress, selected sigma ut, and the applied force, they are far difference. That means it will be 130 megapascal and it's 10 megapascal. So what I want to mean, if I consider in terms of sigma, that is the applied stress, the force. So it's clear that if I have a room of 10 megapascal, if I consider the maximum stress I will apply in the body is 180 megapascal. If I consider the minimum force applied is 60 megapascal. So what I have understood from this thing in a simpler ways, as per rule of third, I have to consider maximum allowable stress is 180. So as I know that it's 190, it's 10 megapascal of window I have, that is maximum. I have 10 megapascal to withstand the maximum force I have calculated. Same for the applied stress here, what the stress I'll apply is 60 megapascal, but here it is 190 megapascal. So the room is 130 megapascal. So what does it mean? That it's safe over here and it's safe over here. So it's better to take a brittle material over the ductile material in terms of the stress, in terms of the amount, and in terms of the of our functionality. Now, if it is so that there should be needed for any extensions, let us go back to the same things in terms of 280. When I will select 280, when I will not select 200, when I will select 190. Now, if I go back to your, let us go for a situation where an extension of material or material extension is mandatory due to force applied. At that time, I have to consider this one. I have to consider the ductile material because I need an elasticity. When my elasticity is my priority, so at that time I will consider this one. That at that time I will have a room of, in terms of maximum stress I have selected to the maximum stress I have, that would be 100, near about 100 megapascal room I have maximum. I have the room of 100 megapascal, and I have 120 megapascal of applied force stress. So this is how it works, that it completely depends on how much force you are applying, how much force you have to apply, and what are the functionality and what are the functionality not, as well as the price. Okay, if you have any queries, ask me. Let us go back to our screen and unblack screen. So let us go back to our this material. What type of material I can get? I could have cast iron. Now this is the stress strain curve of the cast iron, and these are the datas. What you can get, there are many types of cast iron. How much is the compositional rate, that is carbon, silicon, magnesium or manganese, also, and so what we have, nickel, chromium. So it depends on what type of materials are applying. So cast iron is prepared. So where it is used, like engine cylinders or bearing surface, or etc, where it is used. So this is what I can do. As per the BIS standard, so we have named the steel. So why it is important to name the steel? Because we are using a certain, as you can see, that even a cast iron has so much variety. Even the same goes for steel. That is, cast iron is nothing but a type of steel itself, but in other way around. So how will you name it? So there are there have been discriminated, or they have been divided in two parts. One is in terms of application and mechanical and physical properties. What are the physical and mechanical properties, as well as in terms of chemical properties. So in two types they have been divided or segregated. Number one is your casting. The principal symbols for this one is like, if it's a steel casting, for use for steel casting, it will be G. If it is for pressure purpose, that's for pressure vessels or a container which will contain an enormous amount of pressures of fluid, that means I have to calculate P. For cold forming, that is for cryogenics. For cryogenics, we could consider D. For rails is nothing but the rail tracks or the slider crank mechanism used to take one object to another place, like what we use in the cranes. We have to use this one. So it goes on. Additionally, is for glass bottles we use B, so etc etc etc. You have to, for gas bottles we use B. So that's completely depends on what are my uses and what is not given. Now this had been much more segregated in terms of, if I go for an example, let's go for a carbon plain carbon steel, and let's go for the alloy steel. The alloy steel has been done, this one has been done in terms of chemical composition, and this one has been done in terms of your physical and mechanical properties. So what, as it is very well known, 30C8, that is 30%, 30 is equals to 100 times average of manganese, 8 is the percentage of carbon. So this is what we have. So this 30 means it is having 0.3% of carbon, and 8 means 0.08% of manganese. So this is what we could tell that. As well as it depends on where it is used and how it is used. So this is where entire thing works. In terms of alloy steels, it is for carbon plain steels, but from when it comes for alloy steels or in terms of chemical composition, it goes for the where I use and which is the driving stress or the driving chemical or driving compound which makes this material or the steel to be more usable and feasible. Now, like for alloy steel, I have 0.05 to 0.8 and so on. So the carbon varies from 0.013, 0.17. So this is what we could name it. So this is what gives us the amount of chromium present in over here. That means the chromium is the maximum amount of the material present in this alloy steel. It is taken for this. It can be a chromium, it could be a manganese, or it could be nickel based, or it depends on the completely how it is designed and how it is to name. So this is the name comes 15 chromium 65. So what does mean 15 means? 15 means the carbon. Since it's a steel, it will have a percentage of carbon, as you have studied material science in your previous semesters, and 65 means the chromium amount. Here it comes 30 means your manganese, the manganese amount of the manganese, and 8 means the carbon amount. Okay. Now this is for the plain or low carbon steel. What are the properties of this? So you just have to go through it. It's the simplest thing what you can get. That way it's very available in your internet and everything. This is the same thing only. Tensile stress, the properties. This all will be asked in your small questions. In the small question, how much is for the alloy steels? How much is for the in your semester's exams? So. This is what I have to, for copper alloy. Now copper alloy, for let us for the brass, what is the red brass composition, nominal composition, and what is the tensile stress. So few things may be asked. So everything you don't have to study. I'll not ask you those. I'll ask you some few questions, how the formula drives and what are the things work. Now, what are the heat treatments for the steel? Why do I need a heat treatment? Because we are mixing some elements with one element to another, to other. So that means we have to do for some heat treatments. Now, heat treatments is nothing but it's used to for pre-crystallization and post and pre-crystallization. So what do you mean post crystallization, and recrystallization? There are two words. One is recrystallization and one is post crystallization, and another one is pre-crystallization. I'll come on this afterwards. What is recrystallization? That means when we heat the material and the atom gets segregated. Let us consider this is two atoms gets segregated and these two gets again matched. Or if you consider this is a grain boundary and one grain boundary, they get the grain boundary is segregated and they forms a single grain boundary, or they may get two small grain boundary. That depends on complete entire my process. So this is what recrystallization means. That is, we are recrystallizing everything. So it could be a grain boundary. In terms of grain boundary, it could be from atom to atom. So it completely depends on what I am working. Now, what is post-crystallization? So post-crystallization is after manufacturing on the material, after providing heat, after providing some heat like casting process or everything. As you know what is casting, it's nothing but a shaping of material when by applying a liquid metal, or like it could be steel, or it could be iron, it could be aluminum, or XYZ. So to get in the perceptive, so we need the heat treatment for that, where it could refine it, or it could actually help us to rectify the microstructures. Now why? Because as if there is a microstructures, there is a gap between microstructures and everything, that means a small, it's a minimum, you can't even you can only see in the scanning electron microscope. So you could see a small crack that would not affect in a single day, 2 days, or 7 years or 17, but after a period of time this stress get internally increases. At a time it will get much more increase and the material will go off. So to have maximum efficiency of material, we have to go for like annealing, normalizing, stress relieving, aging, quenching, tempering, selective heat treating, differential hardening, flame hardening, induction hardening, case hardening, cold and cryogenic treating, and carburizing. So these are the types of the heat treatment what you have to know. Now to be in short, what is annealing? Annealing is nothing but you could see that after applying a heat specific on the cooling rate, it will be after one, it will be depends on the atmosphere, and it goes from 1 point of 1.2, it gets the heat is released is in a period of time. Now normalizing, we could see that it's provide how it happens, it gives grain composition, etc, etc. So everything the heat treatments you can do. So there are only your 13 given, but it is actually more than that. It are much more detailed heat treatments and everything. So we'll learn about more things, how heat treatments works in the coming classes, and how heat treatment affects our material. So there are some failure theories, or this is the theories of failure of material. So how it works and what are the given material. There are actually 5 of them. So scientists and researchers have came up with 5 of the theories. So how it works and what are the conditions? As you know, maximum principal stress. If a maximum, the word itself says everything. If there is a maximum principal stress, as Subhrata sir has taught you in the previous semester, the principal, if there is a maximum principal stress, that means there may be a chance of failure. If there is a maximum shear stress, there is a chance of failure. If there is a maximum principal strain, there is a chance of failure. If there is a maximum total energy, strain energy, there may be a chance of failure. For distortion energy, same goes. So this is how every stress markers work. Now, what we need to understand is what is factor of safety at first. Factor of safety is the ratio of maximum allowable stress to the working stress. Now, what is maximum allowable stress? The maximum allowable stress is the maximum stress a material can take by the maximum working stress. That the stress you will apply on the maximum stress apply in the body. If a factor of safety is more than 1, that means it's completely safe. If it's less than 1, there is a chance of, or if it is less than, if it is 1 or less than 1, that means you are in a problem, in a dangerous problem. So factor of safety depends on three criteria, that is functionality, safety and longevity. So functionality is depends on how mathematical. There are two aspects again, theoretical application and practical application. The functionality in theory, it depends on mathematical simulation and forecast. That so as I was telling you that the estimation is done in terms of the field situation. So what do you mean field situations? How many types of fields, how will you work in the field, how it will work in the field. Does it need twice the stress? That means the maximum allowable stress should be twice the working stress or thrice. That completely depends on the functionality. Third is your safety concerns. Again comes to the safety concerns. As I have considered in the material, the factor of safety also does the same. So as the word says, it's a factor of safety. That means you have to take in terms of safety. That means you have to take a stress, you have to calculate the stress and everything in terms of safety. That means one will be as we know that it is done on the terms of calculation basis and on the field basis. Calculation on theory basis and practical on the field basis. And longevity as same as the same like mathematical as well as the field. So what is the difference comes? In terms of safety, it comes the maximum priority comes on the maximum number. If you get a maximum safety, you have calculated, if in theoretical application you see the maximum factor of safety comes over here, because if you consider the whole thing, then you have to consider, you have to go for the theoretical approach theoretical approach factor of safety. If a theoretical approach factor of safety is less than the practical approach factor of safety, then you have to consider the factor of safety of the practical approach. So everything works on, everything needs a distinctive way. So what we consider is that we just go through the entire thing, we try to understand the entire phenomenon, how it works. Now stress strain analysis, we know that stress strain analysis, we know this is our this is the stress strain curve for at certain angle, certain degree. Now why I am coming on these things, why it is so important. Stress and ductile and brittle material is completely depends on material, on the temperature. So why the temperature is so mandatory? Because we know the temperature is what makes your recrystallization and crystallization everything. So for you is the it's mandatory to understand the transition temperature. There is a certain temperature for which a material can be a ductile, can behave like a ductile material, and material can also behave like brittle material. That means you can't completely say a material to be ideally brittle or a material to be ideally ductile. A material which is brittle in room temperature may not be brittle in the in higher temperature. It may act like ductile, or it may act like ductile in lower temperature also. So that it completely depends on the transition of temperatures. So this is completely a stress and strain, as well as the behavior of the material, as well as the property of the material depends on temperature. That means you have to go back to the material properties and etc. Now last part is the brittle part. This is your strain in terms of your temperature, like it's given of 80 degree and it's 100 degree, and the percentage of strain. So it changes with a same material with different temperature, the strain changes. That means the stress will also change. So we could actually conclude that it completely this thing is dependent on temperature. So the temperature is what makes a material dry from ductile to brittle or brittle to ductile. Thank you, thank you, my dear students. If you have any problem from in this entire topic, contact me. There will be certain basic concepts questions for you in the exam, and I will hold a online exam of your module 1 after this week. After this week, that means after 9th expected, I'll conduct an online exam. You have to apply for, you have to give the online exam in Google class. So everyone is requested to join in the Google classroom. Thank you. Be safe, be home.